Hey team, I'm Maddie. Welcome to ScienceSideUp, and today we're going to talk about chemtrails. Still not a thing. Chemtrails, not a thing. Never been a thing. What do you mean chemtrails aren't a thing? Look at this photo. And this one. And they're even in Animal Crossing. Well, let's think about this like a scientist. We have an observation. Our observation is that oftentimes behind planes, we see linear white features. So what is the most logical explanation for that feature? To talk about that, we need to understand the concepts of saturation and how saturation is a function of both temperature and pressure. So to demonstrate that, I'm gonna have you guys join me in my kitchen. Oh, hey team, welcome to my kitchen. Forgive its untidiness. I would blame it on all of the quarantine stress baking, but no, it's always messy. What we need to talk about to understand why chemtrails not a thing, never been a thing, and there's a much simpler explanation, is we need to understand the concept of saturation. And that's not the most intuitive topic in meteorology. It's something that, we spend a lot of time talking about. We spend a lot of time talking about how much water vapor can the air hold. And that depends on temperature and pressure and lots and lots of things. But we're not gonna go into all of those details, right? What we're gonna do is we are going to make some tea. So this is just me getting a couple cups of water and a cup of sugar to demonstrate saturation effects. But when I was filming this the first time, I inexplicably rambled for minutes about how the only place you could find proper sweet tea in Boston is at the Raising Cane's on BU's campus. So I didn't think you guys would really want to listen to that. Hi. What I want you to notice is all of the sugar that's settling at the bottom. So what that means is that this the liquid part here, still a lot of sugar in there, right? But this is saturated with sugar. So it can't hold any more sugar in the water. And so all of the sugar that it can't hold just falls to the bottom. So if we were thinking about this in terms of water vapor, how much water vapor the air can hold instead of how much sugar my cup of water here, or my 2 cups of water here can hold, that would mean that if this was saturated air, then all of the water in here would be water vapor. So it would be water in its gaseous form. And then this, what here is the solid that has precipitated out of the solution in the atmosphere. That would be liquid water that we would see as a cloud. The next thing that we're going to do is heat this up. And I'm probably going to make some peach sweet tea out of it because I actually don't have a lot of sugar left because of aforementioned quarantine stress baking. And I don't really want to waste it. And I mean, let's face it, sweet tea is delicious. Bam, flips the camera around, fixed my problems. All right, so you can see, hopefully there's still, as we're starting to heat this up, there's still a lot of sugar at the bottom. I am gonna stir this a lot because sugar does burn very easily, and I don't want to burn anything. That would be preferable. So notice, like, we're up to about 100 degrees, and pretty much we've got like a clear solution here, right? Pretty much all of that sugar is dissolved. Oh, hey team, welcome back to the garage. Oh my God, it's so sweet and peachy and delicious. So now we have a basic understanding of what saturation is, but something that we weren't really able to demonstrate in the kitchen is that the relationship between saturation and temperature is an exponential one. So let me sketch you guys a graph so we can talk about that. So on this graph, my y-axis represents just how much water vapor is in the air. And then the x-axis represents temperature. And the magenta curve that I drew in represents the saturation curve. So if I have a happy little air parcel over here, then all of the water in here is going to be gas. But if I'm on this side of the saturation curve, then my air parcel has more water vapor in it than it can hold, and so you'll start to see liquid precipitate out. So I probably should have drawn this as like a box. All of the water vapor in this box is a gas, and if we moved over here, we would form a cloud, because over here, this is just like the sugar at the bottom of the measuring cup. Whatever extra water there is going to condense into a liquid, which we would see as a cloud. So back to chemtrails, finally. The exhaust of a jet is really, 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 really hot, something like 9,000 degrees Fahrenheit. And the air outside is cold, comparatively. So what we can do is have two unsaturated air parcels. Let's say we have one here, that's just the regular air at the height that the plane is flying. And then one over here, which is like representative of the exhaust. Then if we take these two and we average them together, right, connect them by a line, we see we get this area. I kind of shaded that poorly, but we have this area where we mixed two unsaturated air parcels to get a saturated air parcel. And when we get a saturated air parcel, oh my goodness, we'll start to get clouds. And so as the plane flies, we mix the exhaust with the air that's up there, and we get a cloud. It forms in the exact same way as any naturally occurring cloud. This is just the high temperature exhaust and mixing with the colder air outside. You can have those two air parcels mix and not end up with something that's saturated. So you can get not a trail. The correct term is condensation trail or contrail, not chemtrail. Because chemtrail implies that the airplane is spewing chemicals into the atmosphere for some unknown nefarious purpose. So like I said at the beginning of this video, we're going to think like scientists. So we made an observation, and then we came up with a very logical reason for why that observation like exists. So the problem with the conspiracy theory of chemtrails, the fundamental problem with it is that it takes the observation but jumps to not the most logical conclusion. And if there's any conclusion other than it's a giant conspiracy, that's the one to go with. Anyway, I hope you guys liked this video. This is not going to be the last time I talk about chemtrails or other weather-related conspiracy theories. I do want to make a quick point. So I grabbed those images from the beginning of the video from the Reddit thread r/chemtrails. And I thought really hard about whether to include the usernames or not on those. And I ended up deciding not to, because from my perspective, that's something that would like embarrass me. I don't want to call out anyone. I don't want to embarrass anyone. I did just want some good pictures of what people claim to be chemtrails. So cheers. I hope you all are well and staying safe. Thank you for checking out this video. If you haven't subscribed to the channel, please hit that red subscribe button. Give this video a like if you liked it. Shoot me a message in the comments. All of those ways of interacting with the channel really help me out. I'm really trying to grow my channel this year. I would love to hit 1,000 subscribers by the end of the year. And I need your guys' help to do that. So thank you for your support, and I will see you all later. Bye, team.